Welcome. This session we will learn how to find absolute maximum bending moment when you have train of point loads moving on a simply supported girder. So let us take the same question where we have worked out in the previous sessions, like 40 kilonewton, 50 kilonewton and 60, 30 are moving on a simply supported girder of 18-meter span with 30 kilonewton load leading. We have worked out for the maximum bending moment at a section in the earlier session. So this session we will work out the absolute maximum bending moment. Okay, so let us see how this is going to be worked out. Okay, so this case, the absolute maximum bending moment, the positioning of the loads is very important. Okay, so how do you position these loads to get absolute maximum bending moment? So there is a condition for this. So if you satisfy that condition, then you will get absolute maximum bending moment. So what is that condition? So first you work out the CG of these loads. Okay, so the very first thing to do is to work out for CG of loads. So once you get the CG of the loads, then the nearest load to the CG you choose. So now the chosen load which is nearest to the CG and the CG that you have worked out, those two shall be placed equidistant from the midpoint of the girder or the beam. This is the condition. Okay, so CG of loads and load chosen, obviously the closest one to the CG, these two shall be equidistant from the center of the beam or the girder. Okay, so this is the condition. So now let us find out the CG of these loads. Okay, so let me just locate these loads. So they're all 40 kilonewton, 50 kilonewton, 60 and 30 kilonewton. So each is 1.5 meters. Okay, 1.5 meters and 1.5 meters distance. So how do you find CG of these loads? Okay, so we have learned in engineering mechanics that the CG can be calculated with the formula WI XI total sum divided by total load will give you the X bar value. So for this finding X bar, you need a reference line. So let us keep any of the loads here as a reference line. So now here I am taking the reference line as 40 kilonewton load. So which means I am going to measure all the distances like x1, x2, x3, all that from this reference line. So try expand this formula, like it is W1 x1, okay, plus W2 x2 plus W3 x3 plus W4 x4 divided by W1 plus W2 plus W3 plus W4. Now just substitute for all the values. So first load is 40. The distance of 40 from reference line is 0 because that itself is the reference line, plus 50, distance is 1.5, plus 60, distance is 3, plus 30, distance 4.5, divided by the total load works out to 180. So this is 2.167 meters. So the CG of all these loads is at a distance of 2.167 meters from 40 kilonewton load. Okay, so just locate that CG here so that we'll have an idea. So it's 1.5 meters till this and 3 meters till this. So it is in between that and close to the 50 kilonewton load. Represent by a dash dot line. So this is the X bar distance. Then this is the CG of all the loads. Okay. Now, once you work out CG of the loads, see that this is now the closest load. The 50 kilonewton load is the closer load to the CG. So the distance between these two, you see, is 0.666, or you can say round it off to 67 meters. 0.667 meters. Okay. Yeah. So now, based on the condition that we have just talked, so these two, like the chosen load, that is 50 kilonewton, and the CG line should be equidistant from the center of the beam. So let us see how you place the loads now. So first draw the beam. So let us say this is the given 18-meter span beam. It's 18 meters. This is the midpoint. Okay, midpoint. So from midpoint, these two shall be equidistant. Means if this is the center of the beam, if I keep the center of the beam here, so to the left half of this distance there will be a load 50 kilonewton, and to the right half of this distance there will be a CG of the load. So such a way you have to keep the loads. So which mean now I shall keep the 50 kilonewton load, okay, like this. Okay, so the 50 shall be to the left of the section, and the distance between the center of this beam and this load is 0. Half this 0.667 distance, 3335 meters, and keep the rest of the loads according to their distance between the loads. This is 40, and again at the same distance you have 1.5 distance, it is 60 kilonewton, and again 30 kilonewton. So rest of the loads, they fall according to their places. Okay, right. Now drop these points for drawing ILD. So once you fix the positions of the loads, now it is to plot the ILD. So now you plot the ILD under the chosen load, because the maximum bending moment always occurs under a point load. Okay, so choose the load as you have already chosen the 50 kilonewton load, the closest one. Okay, So now this is the ILD for bending moment under this 50 kilonewton. Okay, so let us say and drop all these loads. Now the 40 shall be dropped onto the ILD, and you drop this 60 and drop 30. Okay, so let this is y1, y2, y3 and y4. So now let us calculate all these loads with multiplied with these ordinates. Then you will have absolute maximum bending moment. So first let us calculate y2 value. Okay, so this distance up to y2 is 8.6665. How you get this? So till C it is 9 meters. It's a midpoint of the beam. It is 9 meters. 9 minus 0.3335 is this much. Okay, multiplied by the right hand side span. So till C it is 9 plus 0.3335. It is 9.3335 divided by total is 18, which works out to 4.5. The highest ordinate is 4.5. Then rest of the ordinates by similar triangles. Okay, so this is 1.5. So this is 8.665 minus 1.5 will give you 7.1665 divided by 8.665 into the ordinate value is 4.5, which works out to 3.72. Then y3, this one. So this is 9.3335 minus 1.5 will give you the distance till y3. That is 7.8335 divided by 9.3335 multiplied by 4.5 will give you y3 ordinate, which is 3.78. Similarly y4, which is minus 3, 9.335 minus this 1.5 plus 1.5, okay, will be 6.3335 divided by 9.335 into 4.5 will give you 3.05. Okay, so these are the ordinates that you can get it from the similar triangle relations. Now to get absolute maximum bending moment, it is simply Wi into Yi, which means W1 Y1 plus W2 Y2, W3 Y3, W4 Y4. Okay, so add all these values, like W1 is 40 multiplied by Y1 value is it's like 4.5 here, Y2, Y1 is 3.72. Under 40 kilonewton, the ordinate is 3.72 plus under 50 kilonewton, the ordinate is the highest value 4.5. Under 60, it is 3.78. Under 30, it is 3.05. So put together, it works out to 692.1 kilonewton meter. So earlier you have seen that in the previous lectures of the same question, at 6 meters we have worked out for the bending moment value, which came out 620. So this is the absolute maximum bending moment that is possible in this 18-meter girder. So for whatever may be the position of the loads and whatever the place that you choose, if you calculate bending moment, it shall come out less than this value. So this is the maximum possible bending moment value that can occur in this beam anywhere in this beam. Okay, so 692 is going to occur exactly under 50 kilonewton load, which is nearer to the center. So to say exactly, it is 0.3335 meters to the left of C. Okay, so this is the maximum possible bending moment. That is what we call absolute maximum bending moment. Thank you.